Hello students, good morning. I am MANDEEP Singh Thakur from Electrical Engineering Department, Assistant Professor at Chandigarh Polytechnic College, Kudua. In this lecture, we are studying about the electrical power system. As per last lecture, we are studying transmission system of electrical power. Let us start with the PPT. Let me share a PPT with you. Today, we will study about the transmission line foundation. Transmission line foundation. In this category, the type of loads on foundation. What kind of loads took place during the foundation of a tower? The foundation of towers are normally subjected to three types of forces. These are the compression or downward thrust, the tension or uplift, the lateral forces of side thrust in both transverse and longitudinal directions due to wind pressure or stormy conditions. Depending on the type of soil and the presence of surface water table, four types of foundation will be used for each type of tower location. The first one is normal dry type. In this, to be used for location in normal day cohesive or non-cohesive soils. Partially submerged type. It is to be used at location where subsoil water table is met between 0.75 meter below the ground line. The third type is fully submerged type. It is to be used at locations where subsoil water table is met at less than 0.75 meter below the ground line. And the next one is wet type. It is to be used for locations where subsoil water is met at 1.5 meter or more below the ground line, which are in surface water for long periods with water penetration not exceeding 1 meter below the ground, or in black cotton soils. In addition, depending on the site conditions, other types of foundations may be introduced suitable for intermediate conditions under the above classification to affect more economy, or for locations in hilly and rocky areas. For locations where special foundations are necessaries. Testing of soil. It is desirable to undertake testing of soil for all the tower locations, and report should be obtained about the subsoil water table, bearing capacity of the soil, possibility of submergence, and other soil properties required for the correct casting of casing of foundation. Here are some tower foundations. The first one is excavation, PCC, stub setting, template alignment, concreting, curing, de-shuttering and template removal, and the last one is backfilling. Let us start with excavation. Excavation means to dig the soil for the plinth of the tower. Excavation on pit on hard rocks, and after the excavation, water excavated pit for softening the soil at that particular area, and after that dewatering took place. The next one is stub setting and template assembly. There are 4 legs for a tower and stubs are set each excavated pit. Here is the picture for step setting to easily understand the actual foundation. This picture belongs to base leveling with sand filling to level the plinth or to level the foundation. Soil, we put the soil at the lower level to plane that area. The next one is PCC. After the sand leveling, the PCC concrete put at the lower area of the stub setting. The next one is raft concrete. After that, concrete took place and fix the foundation or leg of the tower. Here is some pictures for stub footing concrete and stub concretes. The next is tower erection. Method of tower erection. There are 4 main methods of erection of steel transmission towers which are described below. The first one is build-up method or piecemeal method. The second one is section method. Third one is ground assembly method. And fourth one is helicopter method. Let us start with build-up method. Build-up method of tower erection. This method is most commonly used in India for the erection of 66 kV, 132 kV, 220 kV and 400 kV transmission line towers. This method consists of erecting the towers member by member. The tower members are kept on ground serially according to erection sequence to avoid search or time lost. The erection progress from the bottom upwards, means from foundation to peak of the tower. The 4 main corner leg members of the first section of the tower are first erected and bolted with the stub settings. The cross braces of the first section, which are already assembled on the ground, are raised one by one as a unit and bolted to the already erected corner leg angles. The cross braces of the first section, which are already assembled on the ground, are raised one by one as a unit and bolted to the already erected corner leg angles. The members or sections are hoisted either manually or by winch machines operated from the ground. After the tower top is placed and all side lacings are bolted up, cross arms are erected as complete unit which are already assembled on the ground. The next method is section method of transmission tower erection. Sorry. In the section method, major sections of the tower are assembled on the ground and the same are erected as units. These units are erected with the help of mobile cranes. Ground assembly method of tower erection. This method consists of assembling the tower on ground and erecting it as a complete unit. The complete tower is assembled in a horizontal position on even ground. In India, this method is not generally adopted because of prohibited cost of mobile cranes and non-availability of good approach roads to tower location. And the last method is helicopter method. In the helicopter method, the transmission tower is erected in section. Sometimes a completely assembled tower is raised with the help of helicopter. This method is mostly used where access to the tower location is limited. Means there is no area to assemble the tower at ground level. The towers are assembled on the workshops, and from where complete units are picked up with the help of helicopter and assembled or put on the stove as a complete unit at the particular location. Tower erection finishing works. All nuts shall be tightened with 1 to 2 threads shall be projected outside the nuts for the assurance of tightening. Punching after nut tightening and tack welding shall be done along with bolt and nut together to ensure that the nuts are not loosened in course of time. The joints shall be painted with zinc paint on all contact surfaces during the course of erection to avoid rustings. And at the end, the finally erected tower shall be truly vertical after erection. Tolerance limit for vertical shall be 1 in 360 of the tower height. These are the some pictures to understand the progress of tower erection. In this picture, all the assemblies at ground level and assembled one by one and raised to the tower height. The main supporting unit of overhead transmission line is transmission tower. Transmission towers have to carry the heavy transmission conductor at a sufficient safe height from ground. In addition to that, all towers have to sustain all kinds of natural calamities. So, transmission tower designing is an important engineering job where all three basic engineering concepts, civil, mechanical, and electrical engineering concepts, are equally applicable. Electrical transmission tower types and design. A transmission tower consists of the following parts. The first one is peak of transmission tower. Next, cross arm of transmission tower and the boom of transmission tower. The next one is cage of transmission tower. Next one is transmission tower body, and the next one is leg of transmission tower. And last, the stub or anchor bolt and base plate assembly of transmission tower. Let us start with the peak of transmission tower. As per the picture shown, we are easily able to understand the peak of transmission tower. The portion above the top cross arm is called peak of transmission tower. Generally, earth shield wire connected to the tip of this peak. And the next one is cage of transmission tower. The portion between tower body and peak is known as cage of transmission tower. This portion of the tower holds the cross arms. The red area in this picture shown the cage of the tower. The next is tower body. The cross arms of transmission tower. The portion from bottom cross arms, these three cross arms, up to the ground level is called transmission tower body. This portion of the tower plays a vital role for maintaining required ground clearance of the bottom conductor of the transmission line. The red area shown the tower body. The design of transmission tower. During design of transmission tower, the following points to be considered in mind. The first one is the minimum ground clearance of the lowest conductor point above the ground level. The second is the length of the insulator string. The next is the minimum clearance to be maintained between conductors and between conductor and tower. The next is the location of the ground wire with respect to outermost conductors. As per transmission tower, to determine the actual transmission tower height, by considering the above points, we have divided the total height of the tower in four main parts. Minimum permissible ground clearance, that is H1, means ground level, the height from ground level to tower body. The second is maximum sag of the conductor, H2 height. The lowest most conductor, the sag of lowest most conductor. The next one is vertical spacing between top and bottom conductors. And the last one is vertical clearance between ground wire and top conductor. And the total of these height is equal to the total tower heights, means H1 plus H2 plus H3 plus H4 equal to total height of the tower. Next is types of transmission tower. According to different consideration, there are different types of transmission towers. The transmission line goes as per available corridors. Due to unavailability of shortest distance straight corridor, transmission line has to deviate from its straight way and when obstruction comes. In total length of a long transmission line, there may be several deviation points. These are the towers according to the deviation given at that particular transmission line. According to the angle of deviation, there are four types of transmission towers. The number one is A-type tower. Angle of deviation is 0 degree to 2 degree. And the second type is B-type tower. In this, angle of deviation between 2 degree to 15 degree. The third one is C-type tower. In it, angle of deviation is between 15 degree to 30 degree. And the last is D-type tower. In it, angle of deviation is in between 30 degree to 60 degree. So, as per the angle of deviations, we are categorize these four towers: class A, class B, type C, or type D tower. The next is types of transmission tower. As per the force applied by the conductor on the cross arms, the transmission towers can be categorized in another way. Tangent suspension tower, and it is generally A-type towers. The second is angle tower or tension tower, or sometimes it is called section tower. All B, C, and D types of transmission towers come under this category. And the next is, apart from the above customized type of tower, the tower is designed to meet special uses as per requirement. The first one is river crossing tower, and the second is railway or highway crossing towers, and the last is transposition towers. These are called special type towers. as per their requirement, where we need it. Classification of tower. Based on number of circuits carried by a transmission tower, it can be classified as: the first is single circuit tower, the second is double circuit tower, and the third one is multi-circuit tower. Now, these are some pictures of cross arms erected and friction works. Next is stringing. Stringing. Stringing overhead connectors in transmission is a very specialized type of construction requiring years of experience as well as equipment and tools that have been designed, tried, and proven to do the work. There are some methods of installing. There are four methods that can be used to install overhead transmission conductors. The first one is slack stringing, the second one is semi-tension stringing, the third one is full tension stringing, and the last one is helicopter stringing. We are discuss it later on the next lecture. And thank you for today. If you have any queries or question, you are free to ask. Thank you. Thank you for today, students.